All right, so in this video, we want to create fireworks. And mainly what this is about is the pop replicate node so that we learn how to use that. What we need, of course, is a popnet. And before we move on, yes, there is already a setup for fireworks. If in your .NET you just type in fireworks, you will find pop fireworks. And this is actually a node that replaces the pop source. So let's put this in and let's see what comes out of it. And what you can see, yeah, there are some fireworks, but for many reasons, and let's make sure that we have it actually on real time, for many reasons, they're not pretty great. There is not much you can change about it. Sure, you can create more rockets, basically, with a higher birth rate. You can change the overall scale of the whole thing, which just basically multiplies everything with a wider spread as well, if you want. But you know, there's not really that much you can do, and I'm not actually sure why it's even there. So let's ignore that and let's build our own version from scratch, which allows us to control the look of every single element separately. And also the very first thing is we can define where our rockets should come from. So let's start there and let's get rid of this thing. And let's use our pop source again. And we want to start with a certain area that our rockets should start from, which this time, actually, it's fine to have the 10 by 10 meter grid because that gives us a very nice scale overall to start with. Maybe we could even go bigger than that, maybe 30 by 30 meters, something like that. So we want them to fly somewhere up here compared to Tommy. And the first thing we want to do here is create some rockets. Now, what we can use, of course, is the already built-in constant birth rate, just to make sure that we don't have that many rockets. So let's lower the constant birth rate by a lot. There you go. And maybe we can even lower this further. I don't know, maybe 10 or something. And then we want to make sure that those rockets actually fly up into the air. And of course, we use attributes and set the initial velocity. Now, they should really go up. So let's give it quite some punch upwards and let's see what happens. And that's already not too bad. So we have to play around a little bit how we want to do it. Currently the spread is not very high, so let's increase that maybe to 10 in X and Z so that the rockets are spreading out a little bit, something like that. I hope you can see that. And it depends really what you want. What's missing here obviously right now is the gravity. So let's add this. Because if you leave this out, you could think, okay, we don't need that. But to create a nice arc from our rockets, they actually have to have a strong start velocity, and then they create this arc in their movement. Maybe you can see that. That comes from being slowed down by the gravity. So you want to keep that in. If you want them to go higher, again, where is Tommy? Tommy is, oh, I deleted it. Tommy is here. If you want them to go higher, of course, you need to give them a higher start velocity, but I think it's not too bad compared to Tommy. So this is already a pretty good start, and of course you can adjust it to whatever you want, but we can see where this is going, and we have a nicer area where the rockets come from because, you know, the whole city is celebrating or something. But the problem right now is that the rockets are falling down at some point, and for this we just use the built-in system that we already know, and that is the life expectancy. So all we have to figure out is, okay, what is roughly the time when the points should die? And I would say maybe something like 80 frames, something around that. So with a frame rate that we have right now of 24, that's roughly 3.5 seconds. So let's put the life expectancy to 4 with a life variance maybe of 1. And let's see if that was a good number. And that's actually not too bad. We just want to make sure that the rockets are not flying too much towards the ground. So the first thing we want to do now is, before we take care of the actual explosion, let's give those rockets a proper trail. And of course a pop replicate we can use for this, and simply make sure that the points that are our rockets leave a trail of points behind. Currently they don't do that, and that is because the points that are emitted in this sphere around our original points inherit the whole velocity of our rockets, which means they have the exact same speed. We don't want that. We want them to basically stand still, or, you know, be created and then just basically fall down. So it looks quite horrible, but it's actually correct. They are born and then they instantly kind of fall down those points based on the gravity. So the first thing I would fix here is to make sure that they don't stay around that long. So to really just create a relatively short trail, we just make sure that under birth life expectancy is much shorter. And let's try half a second. I'm not sure if that is working, but that should already look more like what we want. Yeah, now they look a bit more like actual rockets. There is something strange though. And okay, so there is still a bug. Jesus. There is a bug for a long time apparently that when you turn the inherent velocity to 0, that the results will not be completely correct. And now I just noticed that there is something strange happening. For example, this point here should move upwards, but for some reason the points are moving to the side. So they have some velocity, it seems, which they shouldn't have because there is no velocity. There are a couple of things you can do. First of all, I think what solves this is just to give it a little bit of a velocity so that the points actually at least a little bit move in the direction of our rocket. Maybe 0.2 or something will help. And I think what happens if you set it to 0, which I just wanted to show you as a concept, it should actually get 0, but it seems like it gets some kind of random number, which I think is a bug. So this is one solution. Another solution is to just make sure you just set it to set initial velocity, and then it will completely ignore any kind of inherited velocity. And if you set everything to 0 here, then you will also get a closer result to what I actually was after, so that the trail is more in the direction of the flying direction of the actual rockets. So it's up to you. Just set the set initial velocity to 0. We will do something with this in a second anyway, or use add to inherited velocity and give it just a little bit of the inherited velocity, so that the direction that you get that comes out of it is not complete nonsense like here. So maybe 0.1 or something should be fine. So it still looks a bit odd. First of all, the scale of it is pretty off, and then we have the classical scattering problem here, the stuttering or the strobo effect. We already know how to solve this. We could either create more substeps, but this would make everything more expensive. A better option is to just change the variance. What we can also do is, in the birth tab, you can change the seed actually, because currently you can see that every single frame the result is the same, and this is why we see a pretty clear pattern here. If you change the seed every frame by just putting it $FF as we've learned, then you can be sure that at least the shape will be different every frame, which just looks a little bit nicer. But it still doesn't solve the stuttering problem, it just makes it a little bit less obvious. So let's change the variance a bit more in Y, and then hopefully, yeah, it should more and more go away. And while we're at it, let's actually make the whole rocket smaller, because they're pretty big compared to Tommy. This is Tommy, and this is, you know, the size of the rocket. It's pretty big in the beginning. What we want is to the trail to become bigger over time, but the main rocket, the front of the rocket, should be relatively small. And of course, this is based on the shape here in the pop replicate where our points are emitted from. So let's lower this maybe to 0.1, 0.1, 0.1. And then you should see that the head is much smaller and it starts to look a bit more realistic. Now, we still have the problem now with stuttering, so I think what we should do now, because we can't do much more with the variance here, I mean, actually we can, let's increase the variance for X and Z as well. But if you still see stuttering, which to some extent is not, you cannot prevent that, so here you still have the strobo effect, then just make sure we increase the substeps, maybe to 3, it will still be pretty fast probably. And here you can see we now combined a more varied start velocity in the pop replicate with a variance for the velocity in X, Y, and Z. And on top we increased the substeps so that we really get rid of the strobo effect. So this is pretty nice. And of course, if you want the trails to be less big, then you just lower the variance here for X and Z, maybe to 0.5, and then it will be less wide. I think that's not too bad. I think I like that. And by the way, a small thing you might want to change, is maybe that you don't want the points to be below the ground, or at least that when they're above the ground, that they collide with the ground. So let's quickly add with a merge and a mutual and a ground plane, a ground to our setup, and then it looks a bit more reasonable because some points, collide with the ground, which is a bit nicer. Okay, so we can still, play around with the color and stuff like that. We will do this later on. But let's start talking about the actual explosions. So what seems reasonable is to just add another pop replicate for the, explosion at the top. But now the problem is when we do this is that the second pop replicate is emitting points for each point of the first pop replicate. So it becomes a big mess. And more importantly, you create a huge amount of points that will make your simulation very slow for no particular reason. What's a better idea here is to basically ignore the first pop replicate. How can we do this? Because we want only the actual original points to create new ones. And you can do this by simply connect them next to the first pop replicate. So let's first look at this in isolation. And of course, what we have now is really what we had in the beginning. We just emit constantly and the points inherit the velocity of the original points. And that's why they kind of stick around it, which is not really helpful. What we want is a big explosion at the very top. So how can we do this? We can actually make sure that this pop replicate only fires when the points are dying, because right before the main point, the original points, our rocket points, are dying, we have the det attribute that we can read out to define, okay, here's a point for just one frame that is currently dying, and then we replicate new points from that. So what we need is the group, and we just look if the det attribute of the current point is equal to 1, which is only happening for one particular frame. So let's see what happens. It's always a good idea to actually connect your nodes, by the way. So let's see, and so there it is. So it took a bit, but the first couple of points are now dying, and then we emit new points which inherit the velocity. And those then just fall down. So while this works, it looks pretty boring because there's no explosion or anything. How can we create an explosion? Well, by shooting out points with a very high velocity in all directions. And this is what we're going to do with the pop replicate 2 under attributes. We don't care about the inherent velocity because it is only happening in one particular frame. So let's set the initial velocity, and we don't want a main direction or anything. We want them to shoot in every direction. So we will only work with a variance here. Let's try 10 for all 3 of the dimensions. And then what we should see is that the points are shooting out, well, kind of, in all kinds of directions. The reason it's a bit boring right now is maybe the speed, but I think it's more, the speed is part of it. So let's maybe increase the variance to 20, but also it's the amount of points. Because what we have right now under birth is 500 for the constant birth rate. You can totally use the constant birth rate here, but keep in mind this is per second. So you would have to calculate this number divided by the frame rate, and then you will end up with something like 20. For this particular case where we have a single frame of an emission, it makes more sense to not use the constant birth rate, but use the impulse count, because then you can define how many points are supposed to be emitted at a particular frame. And then when we start this, we can see, there you go. Okay, now it looks interesting. And maybe now we can see the velocity was a bit too high. So let's lower this maybe back to 10. And also what you can see, the problem is those points after the explosion stay around forever and even reach the ground. That's not what we want. They should disappear because they burn away. So we change the life expectancy. And I think we have to set this pretty low. And as you've seen before, I usually do a main number and then half of that for the life variance. It's just a good default that usually works quite well. So let's see. Let's just make sure that we delete the cache by pressing Control on the brain, that we're not just seeing something that is maybe an old version of it. Yeah, okay, that was a problem actually. So be careful. Sometimes because it looked exactly like it was before. Sometimes it might not notice that you changed something, so make sure that your cache is deleted. And this looks much nicer. And actually, we could argue, let's let the points live a bit longer even, maybe 0.5 instead of 0.3. And you can see that this is now much more like an explosion. So you have to decide how, how fast the points should be. I think that's actually not too bad. The only thing is the life expectancy. It's a bit annoying. It seems like the current version of Houdini does not recognize the life expectancy in a pop replicate as a reason to recache, which is really annoying. So again, make sure to check if your cache is actually updating. If not, make sure you do this yourself. And let's check again with 0.5. Yeah, and I think that's actually not too bad. It starts to really look like fireworks. So now how do we combine this with our original pop replicate to add the trails to it? Well, you guessed it, we just merge them together. And then both of them together, each with their own job basically, look like this. And okay, we could now adjust this a little bit. Let me actually do this. The pop replicate, I think, should be a little bit faster. And I think the trail thickness of my rockets can be a bit smaller. So that's the first pop replicate. And let's lower the spread a little bit for this. And actually, if you want, you can give those some reasonable names. Replicate trail, replicate explosion or something like that. So let's also create more explosion points. I think 200 might be better. And now let's have a look. Oh yeah, and also I think the explosions should happen a bit earlier. I find them a bit too late. So this is something in our original pop source for the rockets. Let's shorten the life expectancy maybe to 3 seconds. And I think I can live with that. That's not too bad. So let's make this even more interesting, because currently our explosions are just made of single points. That's a bit boring. Let's give them some trails, just like our rockets have. And this is straightforward. We could just copy the replicate we already have, or we create a new one just to kind of repeat the whole process again, because it's a couple of steps we have to remember. And by default, it just creates, this sphere, which is an area around the point where the points are scattered. So first of all, let's lower the size of that thing. And then let's make sure that we don't inherit the velocity by setting an initial velocity of 0 for now. Let's see how this looks like. Yep, and that already looks much more interesting. Just you can feel it's getting really slow, and that is because it creates a lot of points right now. So let's lower the number a little bit, maybe to 200. And also you can see the stuttering problem again. So how did we fix that? Well, we could increase the substeps, or we just change the jitter birth time to negative so that it interpolates between the positions automatically when it's born. And that looks better. The stuttering is to an extent gone, but the reason it still feels like a stuttering is that each blob of points looks the same. And we can change that by making sure that the seed is different for every frame. So let's just put in here $FF, so every subframe gets a different shape, and then I think it should be gone. Yeah, that looks much more interesting. Nice. And from far away, you can see that's not too bad. Actually, now I realize maybe I still have too many points. So let's lower this maybe to 100 points. And also, if I keep running this, you can see the explosions just fall down and they will reach the ground at some point. That's not what we want. So let's lower the life expectancy maybe to half a second. And let's see if that makes sense. And let's rewind. And I think that looks pretty good. That's a much higher quality than the built-in system that we had, and we can still change all kinds of things. Now, of course, what's obvious is what's missing here are the colors. So let's finally fix that. And here it's cool that we have separate branches for the two elements. And actually, let's quickly call this explosion trail. And with a pop color, we can just drop one here for the rockets and make this orange. Let's say, just for now, and let's see what happens. And cool, that looks good. So the trails are orange and the explosions are still white. So let's copy the pop color for the second branch and turn it pink or something. And you can see that seems to work. So that's the overall idea. You know, you can use the pop color for separate branches, which is nice. But of course, it's pretty boring that they all have the same color right now. So let's change that. And you might think, well, sure, we can just set the pop color to random. But what then happens is that the randomizer is using the ID to create a random color. And that means every point that comes in from the top that has a different ID, which is all the points, including the trail, will have different colors. So the same is actually true if you would try that with the rockets. For some reason we have to rewind to see this, but here you go, it's the same result. Interesting, of course, but not really what we want. Maybe that is an effect you would like to have, but we want all explosions to have specific random colors. So what can we do here? We can actually just set the pop color before the replicate, because what's happening then is that the points that come from the source, the rocket points, will have random colors, and the next pop replicate nodes will just inherit that color because of this parameter here under attributes, inherit attribute star. It just takes everything that comes from the input and inherits it. And this actually seems to solve our problem, because now we have actually different colors per rocket and also different colors per explosion. But as you can see, even though it looks pretty cool, why the hell we have actually two colors for each rocket, if you look closely, and each explosion? This has to do with the way DOP networks work. What's happening here is that we basically created two different sources, because we have one pop source up here, then we branched them off and merged them back together, and that would be the same as having two pop sources both going into the solver input. So we have a problem here. We basically create at the same time two rockets and therefore two explosions, which again looks interesting but is not intended. Now, how do we solve this? There are two solutions for this. The first one is built into our system here, and that is here in the pop replicate there is a second input called a reference stream. And this is exactly for that reason, so that you don't create additional data. So we disconnect the first input and use the second input, and now it uses the stream without recreating it. It's just referring to the already existing one. So as you can see, this works, but there is one problem with that, and that is the pop color 2 here now has no effect. So let's try it. For example, we have a yellow rocket here and then a yellow explosion. There it is. And we want to have them in two separate colors. Currently the pop color 1 and pop color 2 create the same color, because when you look here at the seed, they're both set to 0. So let's change the seed of the second one. And what you would expect is different colors, but that's not happening. And that is because basically this node here is ignored. When you use the reference input, then what happened with a non-existent, so to say, stream up here will be ignored. So you would have to do it afterwards, which can be a bit complicated because then you need to find another ID and all that. But there is maybe an easier way of doing the same thing, and that is what a pop stream node is for. It basically does the same thing. It refers to the, well, actually it refers to all the points in your scene, but it does not recreate them. So it doesn't evaluate the pop source twice. It just refers to whatever comes out of our simulation. So let's try to just connect everything we have so far, and let's make sure that our pop color is going into the first input, because this is now a normal stream, but up here is the reference. And when we run this now, we can see it actually doesn't fully work, because it actually works too well, because currently the explosion, our replicate explosion, is happening on the trails. And why? Because in the moment the trail points die, the explosion will be triggered via our det attribute. That is because the pop stream refers to all the points in our scene. So the simple solution is here, make sure if you only want to work with what was created up here, that you actually use the group that is created with this node. So under stream there is a stream name, the source first input, and you can actually just choose this from the source group. There it is. So we don't want the explosion trail, for example, or the replicate trail. We want the stream source first input points only. And this would basically be the same as if we connected it to the source without actually creating new points. And now the whole thing should be fine. Yes, that looks good. And the explosion is only happening for the det main streamers. And as you can see, what also works now is that the rockets have a different color than the explosion. And that is because this pop color here now has a different seed than our rocket color. And this is why this works. So the pop stream can be a really helpful solution to use an existing stream without doubling it. So yeah, this is now our result. Sure, you could still improve the quality of this and do much more with this. Feel free to experiment around, but it surely is better than the weird preset fireworks system. And mainly what this was about is to explain to you the problems of the streaming and how to use the replicate node. So I hope this is helpful. Thanks very much and see you later. Cheers.